Question number 11. If the matrix A is both symmetric and skew-symmetric matrix, then which of the following option is correct? So this is kind of a direct question. So whenever a matrix A is both symmetric and skew-symmetric, then that is possible only if the matrix A is a zero matrix. Let me show you an example. Let me make a zero matrix of order 3. Suppose there is a matrix A. So as you can see here, all the diagonal elements are 0, which is a property of skew-symmetric matrix, and all the mirror elements are equal to each other, which is a property of symmetric matrix. And in a skew-symmetric matrix, the mirror elements are negative of each other. So this zero matrix will satisfy the both condition of symmetric and being skew-symmetric. That's why my correct option for this question is that A is a zero matrix. Question number 12, we have to find the value of this determinant. So let us solve this determinant. We will apply row operations here. So let us multiply the first row with A, second row with B, and the third row with C. If I multiply first row, second row, and third row with A, B, and C respectively, then obviously I have to divide by A, B, and C outside the determinant. So here inside it will be A by A, B, C, and A to the power 4. Multiplying second row by B, then it will be B over B, A, B, C, B to the power 4. And the third row with C, then it will be C over C, A, B, C, and C to the power 4. This will be equal to 1 over A, B, and C. So if I simplify, then it will be 1, 1, 1. The column 1 is 1, 1, 1. Second column is ABC, ABC, and ABC. And third column is A to the power 4, B to the power 4, C to the power 4. Now in second column, as we can see that there is ABC, ABC, and ABC. So we will take out ABC common. Then it will be ABC over ABC, determinant 1, 1, 1. Second column also 1, 1, 1. And the third column is A to the power 4, B to the power 4, C to the power 4. Now since here the column 1 and column 2 are identical, that means the value of this determinant will be 0. And 0 into 1 will be equal to 0. So my final answer for this question is option D, that is 0. Question number 13. Let A be a square matrix of order 3 by 3 and determinant of A equals to -7. Then we have to find the value of this expression where capital Aij is the cofactor of the element small letter Aij. So now here I have written one important note about the matrix and determinant, that if the elements of a particular row are multiplied with the corresponding cofactors of the same row, then the sum of those terms equals to determinant of A or else equals to 0. Okay, so here's a matrix A of order 3 by 3, and it's given that determinant of A equals to -7. Okay, now here we have to find the value of A11 into cofactor of the element A21 plus element A12 into cofactor of element A22 and element A13 and the cofactor of element A23. Now if you notice, this A11, A12 and A13 are the elements of first row, and all these elements of first row are getting multiplied with the cofactor of the second row. So here, according to the note, if the elements of a particular row are multiplied with the corresponding cofactors of the same row, then the sum of those terms equals to determinant of A or else it is equals to 0. So according to the note, my answer for this question is 0. If the question would be like this, if the question had asked to find the value of A11 and cofactor of the same element A11, and A12 times the cofactor of the same element A12 plus the element A13 and the cofactor of the same element A13, then this sum would be equal to determinant of A according to the note. But here the elements of first row are getting multiplied with the cofactors of the second row and they are getting added. So this time, so whenever this kind of situation is there, then the sum is always 0. So this was a very important note for this question. Question 14. We have to find the value of determinant of A, and there is a matrix A which is given, and if we note that the order of this matrix is 3 by 3, that is the order is odd here. Okay, and if you see all the diagonal elements are 0 and the mirror elements are the negative of each other, that means the given matrix A is a skew symmetric matrix. So let's read the note here. If there is a skew symmetric matrix and if its order is odd, that means if the order is 1 by 1, 3 by 3 or 5 by 5, then it implies that determinant of this type of matrix will always be equal to 0. So for this question also, my option is B. Now, what if there is a skew symmetric matrix of even order? Then that time the determinant of A may or may not be equal to 0. But if there is a skew symmetric matrix and if its order is odd, then you can write the determinant of that matrix equals to 0. So these questions were conceptual, no need to solve everything. Question number 15. If for a triangle ABC, so there is a triangle ABC. So there is a triangle ABC, and here small letter ABC represents the angle. The value of this determinant equals to 0, then we have to find the value of sine square A plus sine square B plus sine square C. So let us try to solve this determinant and let us try to find the value of A, B and C. Before expanding the determinant, let me do some row operations. So let us change row 2 to row 2 minus row 1 and row 3 to row 3 minus row 1. Then the determinant will be, the first row is not changing, so first row will be 1A and B. The second row is 1. The second row is changing to row 2 minus row 1. So we have to subtract 1 minus 1, C minus A and A minus B. So 1 minus 1 is 0, C minus A and A minus B. Similarly, row 3 is changing to row 3 minus row 1, that is 1 minus 1, B minus A, C minus B. So it will be 0, B minus A and C minus B equals to 0. Now let us expand this determinant using the first column, so plus minus plus. So on expanding we will get 1, then cross multiplying these two elements, that is C minus A into C minus B minus multiplying these two elements B minus A times A minus B, then this minus 0 plus 0, and this determinant equals to 0. So now let us simplify. BC square minus BC minus AC plus AB minus BA minus B square minus A square plus AB equals to 0. So here it will be, on simplifying we will get A square plus B square plus C square minus AB minus BC minus CA equals to 0. So now let us multiply both sides by 2, then it will be 2A square plus 2B square plus 2C square minus 2AB minus 2BC minus 2CA equals to 0. Now this 2A square can be written as A square plus A square, similarly B square plus B square, 0. Now this A square minus 2AB plus B square can be written as A minus B whole square. Similarly b square minus 2bc plus c square can be written as b minus c whole square, and the remaining term can be written as c minus a or a minus c whole square equals to 0. Now here one important thing, that this a minus b whole square, that means this is the positive term, the second term is also positive, and the third term is also positive, and all these terms are getting added to 0. Now this is possible only if the first, second and third term are equal to 0. Okay, so here it implies a minus b whole square equals to 0, b minus c whole square equals to 0, and a minus c whole square equals to 0. So from this we will get a equals to b, from here b equals to c, and from here c equals to a or a equals to c. So seeing all these equations, we conclude one thing, that a equals to b equals to c. A, B, C were the angles of the triangle. Since all the three angles of this triangle are equal, that means this is none other than an equilateral triangle. That means the value of A, B and C will be equal to 60 degree, because all the internal angles of an equilateral triangle are 60 degree. We need to find the value of this given expression. So sine square A is sine square 60 degree, sine square B is sine square 60 degree, and sine square C is sine square 60 degree. So there are 3 sine square 60 degree, and this equals to 3. Sine 60 is root 3 by 2, and root 3 by 2 whole square is 3 by 4. So it will be 9 by 4. That means the correct option for this question is option number D, that is 9 by 4. Question number 16. Here it is given when x not equals to 0, then there is another function, and when x equals to 0, then the function is k plus 1 over 2, and this function is continuous at x equals to 0. Then we have to find the value of k. So the question has already given that the function is continuous, and whenever the function is continuous, the limiting value of this function and the functional value are equal. So first let us try to find a limiting value and functional value, and let us make them equal, and in this way we will get the value of k. So here, while finding the limiting value, we need not find the left hand limit and right hand limit separately, because as you notice here, the function is same when x not equals to 0. That means whether you approach 0, when you approach 0 from the left hand side or from the right hand side, the function is same. So we can directly find the limit. Your limiting value will be limit x tends to 0, f of x will be equal to limit x tends to 0 sine of 5x by x equal x square plus 2x. Here when x is approaching to 0, then the function is this. So in order to solve this limit, let us take out x common from the denominator. So here it will be x plus 2. Now let us separate the limit. So we can separate like this: limit x tends to 0 sine of 5x over x into limit x tends to 0 1 over x plus 2. Let me multiply and divide with 5. So here it will be 5x, and let us multiply with 5. As x tends to 0, 5x also tends to 0. Okay, so we can write, so as x tends to 0, 5x also tends to 0, then this part will be 5 limit 5x tends to 0 sine of 5x over 5x into, here in the second part we can put the value of x as 0, then it will be 1 over 0 plus 2. So here it will be 5 into, now this portion, limit 5x tends to 0 sine 5x by 5x is 1 into 1 over 2. So that means my limiting value is 5 over 2. So here functional value is f of 0, and we know that when the value of x is 0, the function is k plus 1 by 2. So now since the function was continuous, then that time the limiting value and the functional value should be equal. That means 5 over 2 will be equal to k plus 1 by 2. So let us equate them. Then we will get k plus 1 by 2 equals to 5 over 2. So this implies k equals to 5 by 2 minus 1 by 2. And on solving, we will get k equals to 5 minus 1 by 2, which will be equal to 4 by 2, and that is 2. That means the correct option of this question is option number D, 2. Question number 17. The points of discontinuity of the function are, so we have to find the points at which the function is discontinuous. Now this function is a rational function, and here we see that the denominator is a cubic equation. Now it is clear that when the denominator is 0, then the function will be discontinuous. So that means we have to equate the denominator equal to 0, and after solving that denominator we will get the points of discontinuity. So let us equate denominator, that is x cubed plus 3x square minus x minus 3 equals to 0. So if this denominator is 0, then the function will be discontinuous. Now in order to solve this cubic equation, so let us put the value of x equals to 1. So when x equals to 1, then it will be 1 cube plus 3 into 1 square minus 1 minus 3. So it will be 1 plus 3 minus 1 minus 3 equals to 0. That means when x equals to 1, the equation is getting 0. That means, looking at this, we can say that x minus 1 is the factor of this equation. So x minus 1 is the factor of this equation. So now if we divide the cubic equation with this x minus 1, then we will get another factors. So now let me divide. So let us multiply with x square, then it will be x cube minus x square. Change the sign. It will be 4x square minus x minus 3. Multiply with 4x in order to get 4x square here, then minus 4x. Change the sign, then it will be 3x minus 3, and let us multiply with 3, so it will be 3x minus 3. So changing the sign, the remainder will get 0. Okay, that means this cubic equation can be written as x minus 1 times x square plus 4x plus 3. Now we will solve this quadratic equation by splitting the middle term. Then it can be written as x square plus 3x plus x plus 3. So it will be x minus 1. Let us take out x common, then it will be x plus 3 plus 1 x plus 3 equals to x minus 1, x plus 3 and x plus 1. So here, in order to get the function discontinuous, then this all should be equal to 0, equal to 0, equal to 0. That means the value of x at which the function is discontinuous are x equals to 1, minus 1 and minus 3. That means my correct option would be option number A. Question number 18. The function is given here and the function is differentiable at x equals to 1. Then we need to find the value of b minus c. So first let us try to solve and get the value of b and c. Then we will subtract them and we will get the desired answer. So since the function is differentiable, that means the function is continuous also. So there is a note we should remember, that if a function is differentiable, then the function is always continuous. But the inverse is not true. Okay, so here fx is differentiable, and that's why fx is continuous also. Fx is continuous, then the limiting value and the functional value should be equal, and the limit should also exist. Okay, so here we will first try to find the limiting value, but in order to find the limiting value, here we need to find the value of left hand limit separately and right hand limit separately, because the function is different when x is approaching 1 from left hand side and right hand side. Okay, so if the function is continuous, then we can say that left hand limit and right hand limit are equal, and these both will be equal to functional value also. Okay, so let us try to find the left hand limit. Then it will be limit x tends to 1 minus f of x. This will be equal to limit x tends to 1 minus. So when the x is approaching to 1 from the left hand side, then my function is x square plus bx plus c. Now let us put the value of x as 1, then it will be 1 plus b plus c. So this is my left hand limit. Now let us try to find the right hand limit. Then it's limit x tends to 1 plus f of x equals to limit x tends to 1 plus, now when the x is approaching 1 from the right hand side, then my function is simply x. So here it will be 1. Now since this is continuous, then left hand limit and right hand limit should be equal. That means this 1 plus b plus c should be equal to 1. So now let us equate them. Then we will get 1 plus b plus c equals to 1. So from here we get a relation between b and c, that is b plus c equals to 0. Now let this be my equation 1. Okay, since the function is differentiable, so now let me differentiate the function here. Then here the function will be f dash x equals to, differentiating we will get 2x plus b when x is less than 1, and differentiating x I will get to 1 when x is greater than or equal to 1. See, I am differentiating directly the question. Okay, and since f is differentiable, that means left hand derivative and right hand derivative should be equal. So here left hand derivative and right hand derivative should be equal. So now let us try to find left hand derivative. Then it is limit x tends to 1 minus f dash of x. Okay, here we will write f dash of x because this is the derivative, and the right hand derivative will be limit x tends to 1 plus f dash of x. Okay, so here it will be limit x tends to 1 minus, function is 2x plus b here. See, I am looking here. Okay, because this is the value of f dash of x. Here if you note, this is f dash x, okay, because this is the left hand and right hand derivative. So now let us put the value of x as 1, then it will be 2 plus b, and my right hand derivative will be x tends to 1 plus, the function f dash x is 1 when I approach 1 from the right hand side, and the value is 1. And since they are equal, that means this 1 and 2 plus b should be equal. So let us equate them. Then I will get 2 plus b equals to 1. So from here I will get the value of b as minus 1. So I have solved and got the value of b as minus 1. Now let us put this value here. Then it will be minus 1 plus c equals to 0, and I'll get the value of c as plus 1. Now the question was asking to find the value of b minus c. So the value of b minus c will be equal to minus 1, and that will be equal to minus 2. So my correct option would be option C. Question number 19. If x to the power m, y to the power n equals to x plus y whole to the power m plus n, then we need to find the value of dy over dx. Let us take a log on both sides. And log of a into b is log of a plus log of b equals to, here it will be m plus n log of x plus y. So it implies m log x plus n log y equals to m plus n log of x plus y. See here, m and n are constant. Okay, now we will differentiate the equation both sides with respect to x. Then it will be m is constant, so ddx of log x is 1 by x, plus n is constant, ddx of log y will be 1 by y, dy by dx equals to m plus n is constant, so ddx of log x plus y will be 1 by x plus y, and we have to differentiate x plus y also. Then it will be ddx of x is 1 and ddx of y is dy over dx. So now we will write dy by dx on the left hand side and try to find the value of it. So let us open the bracket here. It will be m plus n by x plus y plus m plus n by x plus y into dy by dx. So let us write dy by dx on the left hand side. So m plus n by x plus y dy by dx equals to m plus n by x plus y minus m by x. Taking out dy by dx common, it will be n by y minus m plus n by x plus y dy by dx equals to m plus n by x plus y minus m by x. So now let us take out LCM. So it will be y into x plus y, and in numerator it will be nx plus ny as my minus ny into dy over dx equals to LCM will be x into x plus y, and in numerator it will be mx plus nx minus mx minus my. So here minus mx plus mx 0, minus ny plus ny will be 0, and x plus y also gets 0. That means it will be nx minus my by y dy over dx equals to nx minus my by x. And again here at numerator the same expression is there. That means dy 1 by y dy by dx equals to 1 by x, and hence the value of dy over dx equals to y over x. So my correct option is option B. Question number 20. Again here we have to find the value of dy over dx. So let me write the given equation. So it is, so this implies x into 1 plus y. Let me take this term on the other side, then it will be minus y root over 1 plus x. Now in order to get rid of square root, let me square both sides, then we will get x square into 1 plus y equals to y square into 1 plus x. Let's multiply, then we will have x square plus xy equals to y square plus xy square. Let us take all the terms on the left hand side, and it will be x square minus y square plus xy minus xy square. Sorry, it's actually x square y here, x square y. So the value of x square minus y square is x plus y times x minus y. And let us take xy common here, then it will be xy common, then here it will remain with x minus y. Now again, okay, by the way, this is all equal to 0. Let us take out x minus y common, then it will be x minus y, x plus y plus xy equals to 0. So either x minus y equals to 0 or x plus y plus xy equals to 0. So from here we will get y equals to x, and from here let us express this equation y in terms of x. So let us take out y common, then here it will be y 1 plus x equals to minus x, and here y will be equal to minus x by 1 plus x. Now since we have got two equations, so we will differentiate both the equations. If I differentiate this equation, we will get dy over dx equals to 1. But as you see, there is not the option of 1, then that means this is not my correct option. So this will not be my answer here. So let us differentiate this second equation. So here it will be dy over dx equals to, let me write minus in front. So we will use quotient rule here. So here first I will write denominator and differentiate the numerator, that will be 1, minus writing numerator, differentiating the denominator, I will get ddx of 1 plus x is again 1 only, okay, whole divided by 1 plus x whole square. So that means dy by dx will be minus, here it will be 1 plus x minus x by 1 plus x whole square. So minus x plus x gets 0, so it will be minus 1 by 1 plus x whole square. That means the correct option for this question is option number D, minus 1 by 1 plus x whole square. This is the correct option.